if I give you one root, can you find the rest of them? Sure. Because this is a cubic, and I gave you 1, but I really gave you 2. Because when I choose an imaginary or a complex, if 2i is a root, then what else is a root? Negative 2i is also a root. Okay. Okay, you can look later, but I want you to stop now and join us. Okay, so we have 2i is our root, and that was the one we were given. So that's where we're going to start. And we're going to do synthetic division and see what happens. So we have 1, 1, 4, 4. Now, before we start, these get ugly and then they get beautiful. And the great part is, this is the one thing in math that you know if you're on the right track immediately. Because if 2i is a 0 of this function, what's my remainder going to be when I get right here? 0. That is our check step. We know if we get 0 here, we did it right. Okay, so we'll bring down the first one. And then we will multiply. And then we will add.
So it would be
Okay.
1 plus 2.
Yes. And then we will multiply. And you know what? Just come right over here and show a little work. Now we have to multiply 2i times this. No big deal. What happens to the I squared? Alright, so it becomes negative 4. So this is negative 4 plus 2i. That's what I get right here. Okay? And doesn't it get nice? Because that just leaves us 2i. Which when we multiply 2i times 2i, we get 4i squared, which is negative 4. Did I get 0? Yes. And so that tells me I am doing this problem correctly. Wouldn't it be nice if every problem we did in math gave you a little check step at the end of every step? Yay, you're right. That little 0 is your happy face. Okay? Now, we do synthetic division by its conjugate, negative 2i. So we're going to bring down the first one. And then we're going to multiply. And this second step is always so beautiful. And then we're going to add. And then we're going to multiply. And we knew what it had to be. And look at there. It's 0. Okay. So, 1, 0 was 2i. The other one was negative 2i. And if my last factor is this, what's my last 0? Negative 1. So my zeros are 2i, negative 2i, and negative 1. And then if you wrote the complete linear factorization, it would look like this. Y equals, or f of x. Oh, I did f of x up top, didn't I? So let's do f of x. F of x equals x minus 2i, x minus negative 2i, which makes x plus 2i, and then we have x plus 1. All right, let's try another one, but this one is complex. So, if 2 plus 2i is a root, what is also a root? 2 minus 2i. Very good. All right, so let's set it up. We're going to take that root, and that's what we'll divide by, the first one we were given. We're going to look to make sure I don't have any zeros, and I don't because I'm not missing any degrees. So my coefficients would be 1, negative 4, 12, negative 16, and 32. Okay, so it gets a little bit ugly in the middle, and then it's nice at the end. So we're going to bring down that first one. When we multiply, we have 2 plus 2i. So when we add here, we have a complex number, negative 2 plus 2i. So now when we multiply, we are multiplying 2 plus 2i times negative 2 plus 2i, which gives me negative 4 plus 4i minus 4i minus 4i squared. No, that's plus 4i squared. Plus 4i squared. And so what happens to that plus 4i squared? It becomes negative 4. So what does that simplify to?
4, 5.
Those are going to cancel. Negative 8.
How would you add?
Okay. Now we're going to add, and we just get 4. And now we're going to multiply. So this one's a little easier. We get 8 plus 8i. And so now we're going to add. And when we add, we get negative 8 plus 8i. Okay? Guys, I want you to multiply this times this. And let's see what we get. We know what we want to get. We want it to be negative 32. It's what we want. But actually do the math and make sure that's what you get. Okay, so this does give us negative 32. Now, could you just go, oh, I know it's going to make 0, so it's negative 32, and just write negative 32 there and keep going? Sure, but if you messed up anywhere in here, you just gave up the opportunity to find that mistake. If you don't actually do this multiplication, you give up your opportunity to guarantee you're right. All right, now let's do the next one. 2 minus 2i. So this is the one where everything gets pretty if we did it right. So we bring down the first one. We multiply, and oh, it's already getting nice. Because everything cancels and we get a 0.
Oh, yeah.
And then when 0 times anything is 0, so it's still pretty. And then 4 times this is 8 minus 8i. And so we get 0. So what I'm left with is x squared plus 4.
X squared.
Yeah, because if I work my way backwards, that's where the x is, and that's the x squared.
Okay.
So I'm left with x squared plus 4. So to find the other 2 zeros, because here's 2, the other 2, I'm going to have to solve this. And so you get plus or minus 2i, that's right. So, my zeros are 2 plus 2i, which I was given, 2 minus 2i, which I knew from what I was given, positive 2i, and negative 2i. So, the complete linear factorization would be f of x equals. Alright, so we have to do x minus all of this stuff. So it makes it minus 2 minus 2i, and then x minus all the second one. So it makes it x minus 2 plus 2i. So please notice, both these signs change in both of these factors. Because we're subtracting the 0. So both signs change. And then we get x minus 2, and x minus the negative 2 makes x plus 2i. Okay, the last one is a you try, and there's a little twist at the end. So let's see how far you can get. Okay, if you're watching the video, you'll see in the notes that the answer is the next one on the screen.